Hey everybody, welcome to Sailing Tips. Today we're going to make a soft shackle with a simple overhand knot, and we're going to load test it and see what happens. Stick around. If you don't know what a soft shackle is, it's really just a piece of Dyneema with a loop in one end and a knot in the other end, and you can open the loop, put the knot inside, and it closes on itself, making a really strong attachment point. I personally use these on all of the running rigging for my sailboat. It makes for really quick and easy sail changes. You can buy soft shackles at your local marine store, but they tend to come in one length and they're really expensive, so it's great if you can make your own. You can buy Samson Am steel at your local marine store as well. It's much more inexpensive than pre-made soft shackles, and you can tie your own with it. The issue is that it's really slippery, and so knots tend to pull out of it. Because Dyneema is so slippery, people tend to either splice it or use highly specialized knots. Those soft shackles you buy in the store either use a diamond knot or a button knot. The diamond knot will hold about 140% of the line strength, and the button knot will hold 225% of the line strength. So that's why people like to use those for tying soft shackles, but they're really complicated to tie. So what we're going to do here is we're going to tie some soft shackles with some much simpler, more common knots, like an overhand knot and a double figure of 8 climber's knot, and we're going to test them out and see exactly what happens. We're going to use 5mm am steel, or 3/16, which has a breaking strength of about 2 metric tons, just over actually, or about 5,000 pounds. And then we're going to use a hydraulic press to try and pull it apart. We can see it's really quite simple. It's a piece of Dyneema, which loops through itself and then back to an overhand knot at the other end. So the way that you make this is you determine the size of the loop that you want, you double it, add a little bit for the knot, and off you go. I've gone and pre-measured another piece of Dyneema here. I've determined the length that I want. I've wrapped it with black electrical tape. Now I'm just going to cut it with a strong pair of scissors. Okay, so now the next step is to line up the ends and then find the middle, okay, which is here, which is exactly what this point of the soft shackle would be. Then you want to determine the point where you're going to feed it through itself. So you come back from that a little bit with your fingers, and then you push the am steel kind of like this. Grab it with your fingers. Take an awl or some other kind of similar device. Try and part the bundles of strands. Now you want to part the bundles of strands and not go through any bundles. You want the bundles to be intact if at all possible. You want it to go right through the middle. Okay, so we've done that with the awl. Now the awl is not quite big enough, so here we're going to be crude and stuff a pen through there just to make it a little bit bigger. Okay, there we go. So now the hole is a little bit bigger. Now what we'll do is we'll come back to the end again, match up our ends, and then we take the long piece, which is this one. We take the long piece and we just sort of push the pen out and chase it through with the long piece. Okay, there we go. Now we've got our loop and our ends kind of match up, which is exactly what we want. Because you want to take a double thickness of the same material, because that's what it'll be folding back and grabbing when it's its own shackle. So you can use another soft shackle, or you can just take 2 widths of the material that you've already had. Close the loop on it tightly. Go to the end. Okay, now you can see it, and you can see that we're actually slightly off center, but that's okay. Then what you do is create your overhand knot here. And you can sort of tighten that up a little bit. Go back to the other end. Make sure this is nice and tight. Milk it all the way down and tighten your knot. Now, there you go. We can just take this out Stuff this through, and we've got a soft shackle. If it doesn't feel quite right, you can just do it again. It's that easy. You can undo this whole thing, pull it apart, use the same piece of Dyneema. It's that easy. Now let's go strength test this thing. Before you try and use a soft shackle or test it, it's really important to make sure the knot is set. So what I've also done is taken the one end of the shackle here, put it around something really solid, taken the other end, grabbed it with a pair of pliers and pulled really hard. Now I can't really do that with my hands here. I've gone and put it around a steel bar and tugged on it. So you can use a winch on your sailboat or something like that. It's really important to set that up. Otherwise it'll slip sooner. So in order to strength test this, we're going to use this 6-ton press. And you can see we've got our soft shackle inserted down here into the press. Let's see what happens here. Continuing to add. Starting to get pretty tight, starting to get pretty tight. Starting to get pretty tight. Okay, here we go. You can see it's starting to, the knot's starting to pull apart. So we can see that that knot did slip out as we kind of expected it would, but it would be nice to know exactly how much force it took to pull that knot out. The press had a bottle jack in it. Well, this is the exact bottle jack from the press. And the bottle jack has a plunger, a ram, and a handle. And if you do the math, you can figure out how much force is applied by measuring the force on the handle. And I've actually done that with this little digital scale. This particular bottle jack has a force multiplying effect of about 150 to 1, which means that for every 1 kilo or 1 pound that I put on this lever, we get 150 out the other end. I actually verified the 150 to 1 force ratio with that jack by taking my truck to a commercial scale and then jacking up the back end of the truck by the differential, and sure enough, it was about 150 to 1. What I found with the Dyneema soft shackle with the overhand knot, I repeated the test several times, and I found that it consistently pulled out at about 1.7 metric tons or 3,750 pounds, 3/4 or 75% of the Dyneema line strength. I wanted to try another knot, which I hoped would be a little bit stronger, but still easy to tie. So I made another soft shackle, but with a double figure of 8 climber's knot, which looks something like this. And I repeated the test, actually a few more times with this knot. And I found that this knot was about twice as strong as the overhand knot. It sustained about 3.4 metric tons or 7,500 pounds before it actually started bending the piece of metal that I was using in the press. So it didn't actually slip out. So I don't know exactly how strong the double figure of 8 soft shackle was, other than that it was more than twice as strong as the overhand knot and 1.5 times the line breaking strength, which is stronger than the diamond knot, which is a typical way of tying commercially available soft shackles. So I consider this to be a success. Despite the overhand knot soft shackle being weaker, I've successfully been using them on my own boat for the last 2 years on my racing trimaran in several high load areas, including spinnaker and screecher sheets, and the point where the main sheet attaches to the boom and mainsail clew, and I've had absolutely no failures whatsoever. One thing that's interesting about boats is that the dynamic loads on the rigging tend to set the knots. So the overhand knots that I have on my boat right now are rock hard, and I expect that if I tested them, they would test higher than the freshly tied one in the slippery Dyneema. Please feel free to leave comments in the section below about your experiences with these kinds of shackles or any other kinds of soft shackles. If you've tested them yourselves, what you found. I'd love to hear from you, and so would the other viewers. I hope you found this video useful. If you did, please leave a like. Consider subscribing to my channel. Thanks so much for watching. Bye for now.